I am going to solve this integral with a trick, but before I get to the trick, I have to do a substitution. So I'm going to let u to be equal to 1 over x, or we can say x to be equal to 1 over u. This is the substitution that I'm using. So dx here is going to be equal to negative 1 over u squared du. Negative 1 over u squared du. So that's the derivative of 1 over u, and now the change in limit. So we see that when x is equal to the lower limit 1/2, we have u to be equal to 1 over 1/2. That is from here. So that is equal to 2. And when x is equal to the upper limit 2, u is going to be equal to 1 over 2. Alright, so the integral in the u world is looking like this. I is going to be equal to the integral from 2 to 1/2. That's the reverse of the limit of x raised to the power 8. X is 1 over u. So this is 1 over u. This one is raised to the power 8 divided by 1 over u. This is raised to the power 8 minus 1 over u. This is raised to the power 6 plus 1 over u. This is raised to the power 4 minus 1 over u. This is squared, and now plus 1. Alright, and now what is an expression for dx? That is negative 1 over u squared, like this, and then du. Alright, cool. So here we have I to be equal to, now this negative, when I switch the limits from 1/2 to 2, that is going to nullify the negative. And now on the top, you have 1 over u raised to the power 8. This is divided by 1 over u raised to the power 8 minus 1 over u raised to the power 6 plus 1 over u raised to the power 4 minus 1 over u squared, and now plus 1, which is the same as 1 over 1, and then we are going to have positive 1 over u squared du. So permit me to bring this 1 over u here to multiply 1 over u raised to the power 8, and then we have du. Alright, cool. So this is what we have, and now I here is going to be equal to the integral from 1/2 to 2 of 1 over u raised to the power 10. This is divided by here the LCM here is u raised to the power 8. So when we do that, u raised to the power 8 divided by u raised to the power 8 is 1, and 1 times 1 is 1, minus this one divided by this, that is u squared times 1, now plus the next one is u raised to the power 4. Next one is minus u raised to the power 6, and the last one is positive u raised to the power 8, and this one du. So we have I here to be equal to the integral from 1/2 to 2 of, you can now multiply top and bottom by u raised to the power 8, right? So I'm going to multiply here by u raised to the power 8, and then I'm going to do the same thing to the denominator, u raised to the power 8, to maintain equality. So now when I do that, I see that this one and this one is going to cancel out beautifully, and now what you are left is this. So we are left with 1 over u raised to the power 2, because this and this one will reduce to 1 over u squared. This is divided by, so 1 over u squared, so 1 over u squared, and this is divided by, the bottom is now u raised to the power 8 minus u raised to the power 6 plus u raised to the power 4 minus u squared plus 1 du. Alright, so this is what we have after the u sub. Now the trick here is to add this integral to the original integral. This is the original integral. So permit me to change the variable here from u to x. So I'm going to have the integral from 1/2 to 2. Instead of u, I'm going to write x. So this is going to be 1 over x squared. All this one divided by x raised to the power 8 minus x raised to the power 6 plus x raised to the power 4 minus x squared plus 1, and then dx. So permit me to add this integral transformed by the u sub to the original integral. So the trick here is to now add I plus I, and that is equal to the integral. The first one is 1/2 to 2 of x raised to the power 8 divided by x raised to the power 8 minus x raised to the power 6 plus x raised to the power 4 minus x squared plus 1 dx, plus the integral transformed by the u sub is going to be the integral from 1/2 to 2 of 1 over x squared at the top divided by x raised to the power 8 minus x raised to the power 6 plus x raised to the power 4 minus x squared plus 1 dx. We see that they have the same limits of integration and they have the same denominator. The denominators are the same, so we can combine them into one integral. So left hand side is 2i, and that is equals to 1 integral from 1/2 to 2. Now we have to sum the numerators, x raised to the power 8 plus 1 over x squared, and this is divided by x raised to the power 8 minus x raised to the power 6 plus x raised to the power 4 minus x squared plus 1 dx. So the numerators will combine to this. So 2i is going to be the integral from 1/2 to 2. The numerator is now x raised to the power 10 plus 1 all over x squared. So this is the numerator, and the denominator is x raised to the power 8 minus x raised to the power 6 plus x raised to the power 4 minus x squared plus 1 dx. So here what I'm going to do is to multiply top and bottom by x squared as well. So here I'll have the x here. So what I'm going to do is to multiply top and bottom by x squared. Right, so I'm going to multiply here by x squared and then here by x squared to maintain equality. When I do that, this one and this one is going to cancel out beautifully, and now the integral 2i is going to be equal to the integral from 1/2 to 2 of the numerator is now x raised to the power 10 plus 1, and the denominator, now multiplying this one, we have x raised to the power 10 minus x raised to the power 8 plus x raised to the power 6 minus x raised to the power 4 plus x squared, and then dx. Alright, so this is what I have. Now, how to solve this integral is to add something and subtract something to the numerator. So what I'm going to do, I have the integral from 1/2 to 2 of x raised to the power 10. I'm going to add something here. I'm going to add everything here at the bottom to the numerator. Right, so let me do that in a different color for you to see. So I'm going to subtract x raised to the power 8, add x raised to the power 6, subtract x raised to the power 4, and then add x squared. Right, so to nullify the effect of this, what I have to do is to add x raised to the power 8. That is going to nullify this one, right? And then I'm going to subtract x raised to the power 6, and I'm going to add x raised to the power 4 and then subtract x raised to the power 2. So see that these ones will sum to 0. So basically I'm just adding 0 to the numerator, and after doing that we have to add the plus 1, that is the 1 here. Alright, and this one divided by the denominator, which is x raised to the power 10 minus x raised to the power 8 plus x raised to the power 6 minus x raised to the power 4 plus x squared, and then dx. So this one, I'm going to group this one into 1 and then the next, this one into 1. So grouping them into two different terms. So 2i on the left hand side is the integral from 1/2 to 2. I'm now grouping this integral into two different integrals. So the first one is going to be x raised to the power 10 minus x raised to the power 8 plus x raised to the power 6 minus x raised to the power 4 plus x squared. This is divided by the denominator, x raised to the power 10 minus x raised to the power 8 plus x raised to the power 6 minus x raised to the power 4 plus x squared dx. This is one integral. And the next integral is going to be from 1/2 to 2 and then x raised to the power 8, that is this guy, x raised to the power 8 minus x raised to the power 6 plus x raised to the power 4 minus x squared plus 1. All this one divided by the denominator, x raised to the power 10 minus x raised to the power 8 plus x raised to the power 6 minus x raised to the power 4 plus x squared, and then dx. So 2i here is equal to, we see that this one, they are just the same. So this one and this one will just cancel out beautifully. And now what you are left is this. So this is 1/2 to 2 of 1 dx. Plus the next one is the integral from 1/2 to 2 of x raised to the power 8 minus x raised to the power 6 plus x raised to the power 4 minus x squared plus 1. All this one is divided by, so at the bottom I'm going to factorize x squared out, and that is going to be left with x raised to the power 8 minus x raised to the power 6 plus x raised to the power 4 minus x squared plus 1, and then dx. And we see that this one is also going to cancel this one out nicely. And now what is left? 2i here is going to be equal to the integral from 1/2 to 2 of 1 dx plus the integral from 1/2 to 2 of 1 over x squared dx. Alright, cool. So 2I here is equal to, now integrating is x from 1/2 to 2, and now integrating 1 over x squared is negative 1 over x from 1/2 to 2. Now let's plug in the limits. 2I is going to be equal to, this is 2 minus 1/2 for the first one, and now this is negative, and now into, this is 1 over 2 minus 1 over 1/2. Cool. So 2I is equal to, this is 3 over 2 minus 1/2 minus 1 over 1/2 is 2. And this is equal to 3 over 2 minus 1/2 minus 2 is negative 3 over 2. And that is equal to 3 over 2 plus 3 over 2, which is equal to 6 over 2, which is equal to 3. So 2I here is equal to 3, implying that I is equal to 3 over 2. And this one is the answer that MIT gave for this beautiful integral. Yeah, so that is how I solved this integral. If you really find that helpful, please give me a thumbs up and subscribe to my channel for more engaging content on integrals. I thank you so much for watching this video, and I will see you in the next one. Bye bye.